Again, we have a congruent term. Okay, so question number 3, this will be question number 4. So it is saying that what does congruent mean? Okay, so first, congruent. So first, I'll read the definition. So in geometry, we say that two objects are congruent if they are exactly the same, meaning to say if we overlap or superimpose them, then they fit perfectly. So let's say I'll take a parallelogram. I was, I was, I wanted to make a square. I'll just make a square here. And one more. I, I'm not sure that I would be able to make the exact same square. So I'll just play a trick here. So what I will do, I will just cut this and I'll copy this and I'll paste this. And so let's say I have two squares. Okay, obviously I have cheated here, but the main idea was to explain you. Let's say this is S1 and S2. So in geometry, what we do, whenever we want to say that the two figures are exactly similar or not similar, exactly equal or exactly same, then we use the term congruent in geometry. So what it means that when if suppose mm, again I have to this cut this. So if suppose I take this square and I keep it on the other square, then I won't be able to find any difference among both of them. So both of them, like, they just stick to each other. Like, it is not a case where this is one square and if I'm just pasting the another square over it, so it is looking like this or something like this. So it should like exactly cover the other one, and we cannot see the other figure um, behind the figure which we have just pasted. Um, so in those cases, we say that the figures are congruent. I cannot put this square here, so um, I'll tell you with another figure, one more figure. And so let's say I have, let's say a figure. Um, no, this won't do any good. I just rub this. I don't want this. Um, let's just say I am making a circle here, and I'll make another circle here. Okay, and I'll return back just a minute. Where was that tool? Shape recognizer. Okay, and let's say I'll just copy this, copy and paste. Okay, so let's say this is one circle, this is another. I'll just say this one is, let's say, C1, this is C2, and this is C3. Now what I'll do, I'll try to cut this figure and paste it on the other figure. So if I'm able to see the other figure, well, basically this circle is bigger, so I'll just cut this C1 and try to put this in the above C2. and I'll put these figures so that these centers or these circles are concentric to each other, and I will see if I am able to see the another circle, then the figures are not congruent. So if I paste it here, you can clearly see that I can see the circle C2. That means that the circle C1 and C2 are not congruent, and I have almost aligned this perfectly so that they are concentric to each other. Now I will go for the just a little bit from here. Just yep. So you can clearly see if I release this figure here, you can clearly see that the two figures are superimposed with each other, and we cannot see the um, we cannot see C3 circle here. So it looks like we have made a circle. Sorry, it looks like we have made a circle and we have just written where is shape recognizer. Yeah. So it looks like we have made a circle and we have written C1 here and we have written C3 here. And the circle is a little bit bolder compared to other ones. But the thing is that this proves that C1 and C2 are congruent. But C1 and C1 and C3, this should be C1 and C2 are not. And hence C1 and if C1 and C2 are not congruent, then C3 and C2 will also be not congruent. Similarly, we have congruence theorems in for triangles, and then we are just talking about congruence, but we have concept of similar triangles also. So yeah, that is I think pretty much all. Like in short, we just take both of the figures, we paste it on each other and see whether we are able to see the other figure behind the first one or the second one, doesn't matter. But if we are able to see the other figure, then they are not congruent. Obviously we might have to align the figures a little bit so that they match, or they, like, we need to align uh, both of them in such a way that um, like the first figure can cover all the sides of the another figure. So our aim is to make the figures congruent, but after rotating the figure for 360 degrees also, if we are not able to find any location where we can just say that the I cannot see the other figure behind this one, then we can clearly say that the figures are not congruent. But if it happens that after some kind of rotation or some kind of adjustment, if the first figure overlaps the other figure completely, then we can say that the figures are congruent. So I'll just say correct solution. Good work.